Good evening, all. Am I audible? Is the slide visible?
Yes, ma'am.
Very good. Very good. The planet Earth, or we call it the blue planet, right? Why blue planet? Because 70% of Earth's surface is made of water. It's water more than the land. Water in the sense it's ocean, which is the largest ocean, the Pacific Ocean.
Oh, okay. The Pacific Ocean is the largest ocean.
Yes, that is the largest ocean.
Yes, ma'am.
Yes. And it was 4.6 billion years ago that the solar system, along with that, the Earth was formed. Oh, the sharing didn't. Once again, let me share. Yeah, hopefully it is visible now. Very good. Yeah. So, Earth is the only planet to be named in English. The word Earth in Old English is a word for land. All other planets name are after the Greek gods, the Roman gods, yeah, from like Mercury. Yesterday we studied about it. Mercury is the god, is the messenger to the god, and then Venus is the goddess of beauty and love, and Earth. We don't know who named Earth as Earth, and Earth belongs to the Milky. That is, Earth belongs to solar system, and solar system belongs to Milky Way galaxy. And till now, we have found that Earth is the only planet to sustain life. So, what about the shape of Earth? If you say it is spherical, well, it's not spherical. It's
Yes, not
an
exactly.
oblate, yeah, it's an oblate spheroid, which means since Earth is rotating in a faster mode, like 24 hours per day, there is a bulge in the equator part and the poles are flattened. So if you say what is if you ask what's the shape of the earth, it's oblate spheroid. And the study of size and shape of earth, that branch of physics is called geodesy. Please don't scribble on the screen. Before 500 BC, people thought that earth was flat. Yeah, there was a time when people used to believe that when we look at the land, we just see flat thing, right?
Ma'am,
So people thought,
now also millions of Brazilians believe that the earth is flat.
yeah, there are a lot of people who believes Earth is flat, but yeah, thanks to the scientists like Aristotle and Pythagoras, thanks to the satellites, thanks to the astronomers, now we know that it's oblate spheroid. Yeah, this is a oblate spheroid shape. And oblate means slightly oblong appearance. And the term spheroid means that it is almost a sphere, but not quite. Now, Earth's formation and evolution. Scientists think Earth was formed at roughly the same time as the Sun and other planets for some 4.6 billion years ago. And when the solar system comes from a giant rotating cloud of gas and dust known as a solar nebula, about that we studied in the previous classes. And as the nebula collapsed because of the gravity, it spun faster and flattened into disk. That also we examined in the previous class, in the first class. We called it, anybody remember the name?
Protoplanetary disk.
It was
Miss
the accretion disk. Yeah. And
accretion.
yeah.
Accretion.
And
Okay.
yeah, most of the materials were pulled towards the center to form the sun. Sorry. And other particles within the disk collided and stuck together to form ever larger bodies, including Earth. You can see here a schematic view of how was Earth back then. Now here you can see Earth's formation and evolution. Scientists think Earth started off as a waterless mass of rock. when Earth was formed, it was waterless. There was no water in it. And radioactive materials in the rock and increasing pressure deep within the Earth generated enough heat to melt Earth's interior, causing some chemicals to rise to the surface and form water, while other became the gases of the atmosphere. Actually, it is believed that it was from carbonaceous asteroids that water came to Earth. When Earth was formed, there was no ocean, there was no water. Now, if we talk about the evolution, then we know that the history of Earth is divided into four eons. So, eons are, longer period of time. So the whole Earth, if you say 4.6 billion years ago, we can call it into four eons. Starting with the earliest, that's called the Hadean, and then there is Archean, Proterozoic, and Phanerozoic. These are the different eons, and the first three eons, which together lasted nearly 4 billion years, are together known as Precambrian. So the first three eons are together called Precambrian, and it took 4 billion years. And that is half, like 50 billion years right now. And evidence for life has been found in the Archean about 3.8 billion years ago. But life did not become abundant until the Phanerozoic. It was in the Phanerozoic, the last eon, life became abundant. So if you are asked in which era life become abundant, it is Phanerozoic. Next question and next slide we say, yeah, Earth's formation again. The Phanerozoic is divided into three eras. Phanerozoic is the last eon and it is divided into three eras. They are Paleozoic, Mesozoic and Cenozoic. In the Paleozoic era, so it was the development of many kinds of animals and plants in the seas and on land. And it was in Mesozoic era, there was dinosaurs. In the Cenozoic era, we are in Cenozoic era, and it is the age of mammals. Here you can see different eras in the Paleozoic era. You can see here in the Precambrian, where the origin of life and first eukaryotes, smaller algae kind of organisms were there. And later in the Cambrian era, first vertebrates appeared, and so on. And here we are in the Cenozoic era where mammals were there. And here, in the Quaternary era, it was humans. Now, about the age of Earth. Many scientists today believe that humans began to evolve 1.4 million years ago, and fish were seen about 500 million years ago. Look at this comparison. It was 500 million years ago, fishes were there on sea, in the sea, and humans just 1.4 million years ago. And Earth's first life forms appeared 3.5 billion years ago. Yeah. Now the structure of the Earth's interior. We know
Excuse
that,
me, ma'am.
yes,
Ma'am, the Earth was only born 4.6 billion years ago. So
yeah,
how we discovered the fishes 500 million years ago?
billion is a larger number. Million is a lesser number. Billion means 10 to the power of 9.
Okay.
Okay, 1 followed by 9 zeros. And million is 10 to the power of 7, right?
Yeah. Thank you.
No problem. Now,
Can I ask a doubt, ma'am?
if maybe doubts can be asked in the end of the session.
Okay, got it.
Is that fine? Please, I'm sorry. Otherwise, there was this problem that lectures are not finished. That's why.
Okay.
Yeah, thank you. Now, structure of the Earth's interior. We know that we do have a crust, And underneath the crust, there is mantle and there is inner core. You can see it in the slide, and there is core in the central. The central part of Earth is the core. Now, let's talk about crust. Outermost layers of Earth. It also the surface of the Earth, and this comprises the continents and ocean basin, and therefore it has been classified into continental crust and oceanic crust. So two kinds of crust is there. You know, the crust where the land is there, we call it continental, and the crust where ocean is there, we call it oceanic crust. Okay. Then the continental crust averages some 25 miles, that is 40 kilometers. Although it can be thinner or thicker in some areas. So it depends, you know, it's not like a very uniform, like if you say 40 kilometers, everywhere in the surface, it's not 40 kilometers. Sometimes it is 40 kilometers, sometimes it is just 20 kilometers, and it depends. And the oceanic crust is usually only about 5 miles or 8 kilometers thick. And in the about the mantle, it's about 2,900 kilometers thick, the mantle. You can see here a schematic picture of a continental crust, and here you can see oceanic crust, which is actually thinner, and here we have mantle. And here, everybody please make sure that your system is muted. Okay, thank you. Otherwise, noise will come. It will distract our classes, right? Okay, now, yeah. The Earth's crust floats on the mantle, much as a wood floats on water. And the slow motion of rock in the mantle shuffles continents around and causes earthquakes, volcanoes, and the formation of mountain ranges. The division between the crust and the mantle. So there is this division which is between the crust and the mantle, and it is called, any idea? Have you heard about it? It's called the Mohorovic discontinuity.
No, ma'am.
You know, the division between, here you can see, right? The division between crust and mantle, this line, it's called Mohorovic discontinuity or Moho continuity, discontinuity. Now we do have a core beneath the mantle. Earth's core is about 4,400 miles. It's actually thicker than crust and mantle. It can be divided into two. The first one is outer core, and the inner core is called, of course, the inner. Okay, that's why we have magnetic field. Now, the transition space between outer core and mantle is called Gutenberg discontinuity. Transition space between the crust and mantle was called the Mohorovic discontinuity, right? Here, between
Yes, ma'am.
outer core and mantle, it's called Gutenberg discontinuity. Now, let's move to the next slide. Yeah, the orbital characteristics. Earth spins on an imaginary line called an axis that runs from the North Pole to the South Pole while also orbiting the Sun. This is the axis of Earth. This is how Earth rotates on its own. There is a tilt for this axis, that is 23.439 degrees. Now, the orbital characteristics. Earth's orbit is not a perfect circle, but it is rather an oval-shaped ellipse, like that of the orbits of all the other planets. Yesterday we talked about it, right? It's not oval shape. Yeah, it's not
Yes,
perfect
ma'am.
circle, but it is elliptic.
It's compulsory to
Elliptical.
have an ellipse according to Kepler's first law.
Yes, that is right. Now about orbit and rotation, some statistics about Earth's According to NASA, here there are some statistics. You don't need to remember all these numbers, okay? Just the equatorial inclination to orbit, that is the axis tilt, it is 23.43. Then there is a length of year, that is 1 year is 365.26 days. The length of, yeah, just like this. Now, let's talk about the motion of the Earth. The numbers are not important, but just the facts are, of course. Now, talk about the rotation. The rotation of the planet Earth around its own axis. The Earth rotates on its axis from west to east or counterclockwise, and the rotation of the Earth results in the alteration of day and night. And areas facing towards the sun experiences daytime, and areas facing away from the sun experiences nighttime. This is common sense, right? Now we do have revolution. Yeah, it takes 365 and 1 by 4 days. So every 4 years, this 1 by 4 days will become a day, and then that year we call as leap year. Now there is this important question, that why does Earth have seasons? Yesterday when we studied about Mercury and Venus, we understood that uh, these planets doesn't have seasons. Why? Because there is no tilt in its axis. Its orbital plane is perpendicular to that of its rotational plane. Now, but for Earth, it's different, because we do have a tilt. So Earth has seasons because its axis is tilted. The sun's rays hit different parts of the planet more directly depending on the time of the year. Summer is warmer than winter, and because the sun's rays hit the Earth at a more direct angle during summer.
Ma'am, I have a doubt.
You can ask it after the lecture, okay? Is that fine?
Okay, ma'am.
Okay. Now, yeah. Now I would like to tell you about, yeah, the standard time. For millennia, people have measured time based on the position of the sun. It was noon when the sun was highest in the sky, and sundials were used well into the Middle Ages. Sundials. Sundials, we do have Jantar
The
Mantars,
clock
right?
using the clocks using shadows.
Exactly. You can see an
The
example
Jantar
of it
Mantar
in
is
the.
a large sundial, right?
Yes, it is the largest sundial.
In the world or India?
World.
Oh, okay.
Yeah. Now, actually, I want to tell you about one more thing. Yeah, here. Locating places on Earth. How do we locate places on Earth? We do have latitudes and longitudes.
Longitudes.
Yeah.
Coordinates?
Yes, they are the coordinates. Latitude means, here you can see vertical lines originating from North Pole and end South Pole. They are called longitude. And what are latitude? Latitudes are marked horizontally on map or globe starting at the equator. It is parallel to the equator, and the longitude is perpendicular to that of the equator. That's how we talk about, in which lat longs you are. There is unique lat long for each of the places on Earth. In which hemisphere we are in? The northern or southern?
Northern.
Yeah, we are in the northern hemisphere. Antarctica is in the southern
Southern.
hemisphere.
Southern
Yeah.
hemisphere.
And miss the longitude line, the like prime meridian divides into west and east hemisphere.
Yes, West Indies.
Yeah.
Okay.
And if the latitudes are divided into north and south. Yes. North means, north of equator, and south means south of equator.
We
And
have the
ma'am,
prime meridian line, and then we have the
the equator.
equator. Yes, equator.
Yes. Okay. Now, NASA studies Earth to learn about how the planet changes. NASA was the first, a few organizations, just like Soviet's space program, which studied about Earth. It was NASA's satellite Explorer 1, which is first NASA's first satellite. It was that satellite for the first time found that there is a charged, particles belt seen in the upper atmosphere that called Van Allen belt. So till since then, even ISRO has a lot of satellites to study about Earth. Japan has, European Space Agency. So basically, why do we need satellite to study about Earth? Because if you are taking samples and studying about the Earth from Earth itself, we can't get the whole viewpoint of it, right? For example, if there is a satellite, you call it, yeah, there is a satellite called Aqua Modus. It's from NASA. That satellite, when it is in the orbit looking at the Earth, it measures the sea surface temperature and how much chlorophyll is there, etc. Just like that, we do have MetSat. And so, yeah, there are a number of satellites now look towards Earth from space. With remote sensing data, they collect different parameters data sets, and the scientists use it for different purposes according to their objectives. Now, there are some amazing facts about Earth. One of it is Earth was originally born as a twin to the planet Theia, which was about half as wide as Earth and roughly the size of Mars. These two planets shared an orbit for several million years.
Yes,
Yeah.
ma'am. Because of this collision only, the moon is formed.
Yeah, yes. And until they collided, Earth absorbed Theia, and the remaining debris eventually coagulated into Earth's moon. And the mass donated by Theia gave Earth the gravity necessary to sustain a substantial atmosphere.
Ma'am.
If there was no such collision, the doubts can be asked at the end of the session, please. The world's largest desert is in Sahara. It covers about 1/3 of Africa. Another fact is stretching out to an impressive length of 6,696 kilometers. Nile is the longest river on Earth. Which is the largest river on Earth?
Nile.
No, it's the longest river. Largest river is
Amazon.
Amazon. Yes, that is right. Now, this is the tallest mountain, the highest mountain, Mount Everest. It reaches some 8,848 meters above the sea level. It's called hotspot. Now, which is the hottest spot on Earth? The Fairy Award for Earth's hottest spot goes to El Azizia, which is in Libya, where the temperature records from weather station reveal it hit 57.8 degrees Celsius. And the coldest spot, it may come to no surprise, which is, of course, it is Antarctica. But the chill factor is somewhat unbelievable because minus 73 degrees Celsius. And the lowest temperature ever recorded on Earth from Russia's Vostok station, where records show the air plunged into a bone chilling of 128.6 degrees Fahrenheit, which is minus 89.2 degree Celsius. So this is the Earth slide. Hope you enjoy the Earth slide, and we will surely go to the Mars slide. Can you see the Mars slide?
Ma'am? Yes, ma'am.
Yes, ma'am.
Yeah.
Ma'am?
Yes?
ma'am.
The largest mountain and the deepest canyon, both of them exist on Mars, right?
Yes, largest volcano. That is true.
Olympus Mons and Valles Marineris.
That is true. So Mars is the fourth planet from the Sun and is commonly referred to as red planet. It's because the rocks and soil have a red or pink hue due to iron oxide. That is called rust, and that's why it is red in color. Mars has two moons, Phobos and Deimos. Just like you already said, the largest, I mean, the tallest and largest mountain that is a volcano that is seen that not only of the
Olympus
planet
Mons.
but in the entire solar system. It's in
Excuse me, ma'am. Can you also
Mars.
Ma'am,
tell the
your
fact?
Sorry?
Ma'am, it is Olympus Mons, right?
Yes, it is Olympus Mons. So meanwhile, I'll tell you what's on the screen. So we were talking about the atmosphere of Mars. The atmosphere is much thinner than Earth's and is comprised mainly of carbon dioxide and nitrogen. And its gravity is about one third of our own. Just one third of our own.
Yes, ma'am.
Yeah. So here we do have
Okay.
our slide, right? Everybody can see the slide, right?
yes,
Yes, yes,
Very
ma'am.
good, very good.
ma'am.
Let's come back to our class. So Mars is the fourth planet from the Sun and is commonly referred to as the red planet. The rocks and soil have a red or pink hue due to the iron oxide. It's called rust. Now, NASA's Hubble Space Telescope view provides the most detailed, complete global coverage of the red planet Mars ever seen from Earth. This picture was taken on February 25, 1995, when the Mars was at a distance of 65 million miles. See, this is the terrain of Mars. Mars has a rocky, dry terrain with huge volcanoes and deep valleys. The atmosphere is much thinner than Earth and is comprised of mainly carbon dioxide and nitrogen. See this? This is the largest volcano in the solar system, which is the Olympus Mons. It is 624 kilometers in diameter and about the same size of, here have you seen the state Arizona, if you have seen, but it's imaginable, right? 624 kilometers. And
Ma'am, is it a active volcano?
is it an active volcano? Let me
There are
see.
no active volcanoes on Mars.
Olympus Mons.
Ma'am, but there are no active volcanoes on Mars, right?
Okay. Although it has taken billions of years to form, this it can be still an active volcano with the potential to erupt. It can be actually.
Ma'am,
Ma'am,
how
has
was
it-
Olympus
has it
Mons?
erupted?
Yes. It's Ma'am, it has
It has
erupted,
been
but
dead
it has
for
not erupted now since 1 to 2 million years.
yeah. It can be erupted till any time. It haven't erupted till long years. Maybe
Ma'am, how
yeah.
was Olympus Mons made?
It's just like Earth. We have mountains on Earth, right? How is it made? Due to the tectonic movements and
When the
it's not.
tectonic plates like rub to each other and like go up and down, so they like. Ma'am, when two
Yes.
plates collide, they go up, ma'am. That's why.
Yeah, and here the valleys. So everybody, please see this mark, big mark. This is called Vallis Marineris, or it's also called the Mariner Valley. It is a vast canyon system that runs along the Martian equator. Vallis Marineris is 2,500 miles long and reaches depths of about 4 miles. This is an important feature on the surface of Mars. So, if there is this question, right, like, I'm sorry, yeah, if there is a question like which is the planet which has Valles Marineris on it, so the answer is Mars. Okay.
Mars.
Earth, Mars has seasonal changes, but the seasons last much longer. In winter, Mars' polar ice cap can reach down to 45 degrees of latitude and then rapidly shrink during spring. Thus, storms are seasonal, also as witnessed in this Hubble image. You can see it. This is the ordinary picture of Mars, and here the picture of Mars when there is dust storms. It occurs, the full planet will be covered with dust storms. It is actually seen in the movie Martian. Now, yeah, there are some vital informations, characteristics of Mars compared to Earth. Distance from the sun. Earth is actually 93 million miles away from Earth, while Mars is 141 million miles away from it. And diameter of Mars is 4,222, and length of year is 687 Earth days. And length of day is actually similar. Martian day is actually 24 hours and 37 minutes. Where in Earth it is 23 hours and 56 minutes. Mars has two number of moons. Now the etymology, which means how the planet was named. It was named after the Roman god of war, Mars, who was one of the most worshipped and revered gods in ancient Rome. Why? Because that time it was all wars, right? And the god Mars held a special place in the Romans' pantheon, not only for his patronly influence, but because of the importance of military achievement in the Republic and the Roman Empire. Now, before the space exploration, Mars was considered the best candidate harboring extraterrestrial life. We didn't know what was there in the Mars. We hoped that we could see, our neighbors on Mars. But, there was this Italian astronomer whose name is Giovanni Schiaparelli. He thought that he saw straight lines crisscrossing the surface. This led to the popular beliefs that irrigation canals on the planet has been constructed by intelligent beings. But later it was found that it could be, the channels through which the lava from the volcano must have flown.
Ma'am, is there water present?
In the polar regions, it may be inside, but not in a liquid form, but water form. Now there was this question. Please mute your systems.
2%, ma'am, of water in Martian soil.
Ma'am, there is a theory that the canals.
Okay, the next slide. Yes, in July of 1965, Mariner 4 transmitted 22 close-up pictures of Mars. All that was revealed was a surface containing many craters and naturally occurring channels, but no evidence of artificial canals or flowing water. See, look at this. There was this doubt like why there are mountains. See, of course there will be mountains because this planet is made out of little planetesimals. How can they be, picture perfect, very flat plains? Of course, there can be sometimes, hilly areas and sometimes, valleys. Hmm. So that's how there is mountains and valleys in any planet. If it is, terrestrial planet, or if the surface is rocky.
Tectonic activity is not the only way mountains and landforms are formed.
Exactly. Okay, now finally in July and September 1976, Viking landers 1 and 2 touched down on the surface of the Mars. The three biology experiments aboard the landers discovered unexpected and enigmatic chemical activity in the Martian soil. It also provided no clear evidence of the presence of living microorganisms in the soil near the landing site. So it was the final result when in 1976 the Viking landers it analyzed the soil and found that there is no life on Mars. Now, according to scientists, it says that Mars is self-sterilizing. Self-sterilizing means we do sterilize our equipment sometimes. Why? Because when we sterilize, there won't be any life present on it. No microorganisms will be present in the thing. So they believe the combination of solar ultraviolet radiation that saturates the surface, the extreme dryness of the soil, and the oxidizing nature of the soil. So these are the different reasons that prevent the formation of living organism in the Martian soil. The question of life on Mars at some time is the distant past remains open. Like, was there life before a long years before? That we are not sure. Now you can see here a rover here. There were a lot of rovers, which examined Mars. Then one of it is Mars Pathfinder and was the first instrumental lander and robotic rover to study the surface of Mars. Finding from the investigations carried out by scientific instruments on both the lander and the rover suggests that Mars was the one time in its past warm and wet with water existing in its liquid state and a thicker atmosphere. So sometimes in the past, that's why we study about Mars because now we do have life. Just like that, it is believed that once, millions of years ago, maybe Mars was habitable kind of planet because there were water existing in liquid state and there was a thicker atmosphere. But as the planet evolved, these things can be changed. Here you can see Mars exploration rovers. Spirit and Opportunity are the current studying how past water activity on Mars has influenced the red planet's environment over time.
Ma'am, Spirit and Opportunity are not there now, right?
Yes, it used to study, but the data is still present. With that data sets, we are still studying. Now, in March 2005, there was a Spirit rover, which studied rocks in the Paso Robles area that have a high sulfur content. Much of the high sulfur is contained in a hydrated iron sulfate mineral that can only have formed in the presence of liquid water. So this is one of the reasons why we see that there was water present on surface of Mars long time ago. There is another instrument called Opportunity. Opportunity spectrometer and microscopic imager found that rocks near the lower slopes of Endurance crater were affected by water both before and after the crater was formed. Such that a lot of landers, rovers, and also orbiters studied Mars. The whole of the Martian, surface is actually mapped already. Yeah, future exploration are, about to come, and there are a number of satellites sent by other countries other than NASA. For example, India, we have our own Mangalyaan, which study about the Mars, and then even UAE also had. So about India, our Mangalyaan mission, or it's also called Mars Orbiter mission, is one of the cheapest mission which could accomplish the successful um, reach
Ma'am,
towards the Mars, towards the Mars for the first time. And after that, there was UAE's mission to Mars. It also was then became the second uh, Mars mission to reach the Mars in first attempt. Yes, so I'll ask you some questions about Mars. Later I will ask maybe a
Mission
mix
even
of.
Curiosity rover is there.
Sorry?
Miss Curiosity rover is also there.
Yeah, Curiosity rover is there. That's right. And after,
even Perseverance.
sorry,
Ma'am, also Perseverance rover is
yeah,
also there.
Perseverance is there. Yes.
Ma'am, there were
And
7 Martian rovers sent by NASA.
Perseverance, ma'am, not about curiosity.
okay, now after Mars, we do have an asteroid belt, right? There are a lot of small rocks, small to large rocks. Some rocks are maybe a handful, but some are bigger than our houses. So let's have a look at these different asteroids present in the asteroid belt. I will share the screen now. Yeah, I hope you can see the screen. Comets, asteroids, and meteors.
Yes, ma'am.
So these celestial objects, the first one is an asteroid, the second one is a comet, and the third one is a meteor or a shooting star. So these are the three things which we often mispronounce, or we sometimes confuse with these three things. The first thing, rocky kind of a celestial object, it is called asteroid, and a dirty ice or ice, mostly ice formed um, celestial object, which will be having a tail when it comes closer to the sun. It's called a comet, and the one we see that just enter into our atmosphere and just splashes off, that's called a meteor or shooting star. Comets and asteroids are referred to by astronomers as near Earth or objects, NEO. Comets are icy bodies or objects, while asteroids are rocky fragments. See, what is the difference between comet and asteroid? Comets are icy bodies. It's mostly it's made of ice, and of course rock particles can be there. Mostly it is ice, and asteroids, they are rocky fragments. Now, comets and asteroids are remnants from the formation of our solar system 4.6 billion years ago. Here you can have a comparison of some characteristics of comets and asteroids. About origin, comets must have been originated from either Kuiper belt or Oort cloud. The Kuiper belt is a belt which is seen after the Neptune, and then there is our asteroid belt from where most of the asteroids are seen. Now, the shape of a comet and asteroid are similar. I mean, it's varied, irregular shape is there. It may not be spherical or having a particular feature in it, but mostly it is irregular shape. Now, size range of diameter for comet is 1 to 10 kilometers maybe, and for asteroid it can be 1 to 100 plus kilometers. Now the important thing, the chemical composition. The chemical composition of comet can be ice, mostly ice, frozen water, and frozen gases like ammonia, methane, and carbon dioxide, and other organic compounds like carbon containing compounds. And in asteroid, mostly it is silicates. Silicate means rocks, mostly olivine and pyroxene, that are the minerals, and there may be iron and nickel present in most of the asteroids.
Ma'am, some asteroids have even nuclear elements, ma'am.
Yes. Okay. Now, yeah, about the orbit of comet, it is highly elliptical because it comes from far end of the solar system. It is highly elliptical, and asteroid, it is more like a round shape. And orbital period in years for comet, it is from 75 years to some, it can be some 10,000 years or so. But for astronaut, mostly 1 to 100 years. Now, comets and asteroids have irregular shapes and varied sizes. They both reflect light from the sun at varying amounts depending on the size and composition. Which is the most important mineral that is found in asteroids? That is silicates, right? Now, silicates are minerals which contain the minerals that, like elements silicon, oxygen, and at least one metal which is responsible for comets and asteroids to be able to reflect light. Now, comets and asteroid both orbit the sun. Yeah, that is one common thing both comets and asteroid has. Okay, they can orbit sun. Asteroids in the asteroid belt, of course, they orbit. Sometimes there are some asteroids. They can be sometimes wandering in the space also. Long period comets come from the Oort cloud, while short period come from the Kuiper belt. Mostly, if there is a comet which is having a longer period means it takes longer times to come back to the sun.
That is because it takes a lot of time to complete its elliptical orbit from the Oort cloud, and from the
Yes, that
Kuiper
is
belt, it's
right.
nearer.
Now about Halley's comet. The most famous comet of 20th century is the Halley's comet, and it's only known for short period, and it takes 75 to 79 years for comet Halley to orbit the sun. Now about asteroids. Asteroids originate from the main asteroid belt between Mars and Jupiter. This belt is theorized by scientists to be the remnants of planets that did not completely form. And the orbit of asteroid is more rounded and less elliptical than the orbit of a comet. And asteroid Ceres was discovered in 1801 by Giuseppe Piazzi, and it is the largest asteroid. Which is the largest asteroid? That is Ceres.
No, ma'am. Now Ceres is a dwarf planet. Now the
Yeah,
big
It
asteroid
is
is
an
big.
asteroid.
Ma'am, Ceres is located in the asteroid belt.
that is right. So that is the biggest object there. Okay,
And also,
that
ma'am,
is mean.
like series,
Okay, please mute yourself, everybody.
ma'am, I want to say.
Did I say that after 1 hour you will be given time to say facts? Asteroids are made of rocks, ice, carbon, silica, and different metals. Asteroids are also called the minor planets or planetoids. Now about comets. Comets come from a farther region, mostly Kuiper or Oort cloud. It is far away. That's why the orbit is elliptical. And comets are made of frozen matter, while asteroids are rocky fragments. Here you can see the different tails. There are two tails. One is the iron tail and the other is a dust tail. Here, for example, a typical comet, two tails you can see here. Now about comets, they are actually dark and invisible. When they come near us to a star, for example our sun, it becomes visible because the tails are formed. When it is far away from the sun, there won't be any tails. Just because it comes nearby the sun, the tails will be visible. When the comet is approaching the sun, the iron tail is behind it, but when it is moving away from the sun, the iron tail goes ahead of it, like this. It's not like the light is away from it. Consider an comet is approaching the sun. Now it is away from the sun, right? And it reaches here, and it will be always away from the sun. When it is going this way, away from the sun, then also the tail will be away from the sun. So this is the position of asteroid, and in the orbit of Jupiter, there are two sets of asteroids present here. These are called the Trojan asteroids. It's not present in the asteroid belt, but in the Jupiter's two side. One is ahead and the next one is later of the Jupiter's orbit. Yes, so this is our location of Kuiper belt and Oort cloud. Here you can see up to Neptune's orbit, and they are the trans-Neptunian objects, which called the Kuiper belt. And Oort cloud is not in the orbital plane, but it is a cloud. Now the last one, meteoroid, meteor, and meteorite. We already discussed about it in the previous class. The meteoroid usually all burns up when it enters the Earth's atmosphere. And a meteor is a light phenomenon or a streak of light that occurs when a meteoroid burns up as it enters the Earth's atmosphere. And when a fragment from the meteoroid survives and makes it to the ground, we call it meteorite. Sometimes we see, a phenomenon called meteor shower. It is when the Earth orbits the Sun and passes through a comet fragments or asteroid fragments, we see streaks of light is produced. That's called meteor shower. Yes. Now the lecture is finished.
Okay.
Yeah. So thank you everyone. Bye.
Thank you, ma'am.